Welcome again. My name is Angelo Streklas from Mobile World Capital Barcelona, and in this video I'm going to help you go through the installation guide of the logistics automation platform, also known as OPIL. So first, we're going to go through to an overview of how the platform is structured. The main core of OPIL Logistics Automation Library, OPIL Server, which communicates with all the application modules such as Task Planner, Sensing and Perception, HMI, BPO. The OPIL server is in control of both the real and the virtual factory, and the whole system is embedded in RAMP, Robotics and Automation Marketplace, where other tools such as data analytics, graphic representation tools, and other applications are also developed and available. The OPIL Logistic Automation Library can be used in two functional phases. One is the planning phase, where we can use simulations and design the layout and the routes and the schedules of any task. And the other is the execution phase, where sensors, robots, or AGVs can be connected to the basic OPIL library core and steer the logistic operations of the industry floor plan. There are some basic prerequisites needed before we start the installation and using the OPIL library. The platform needs to be operated in a Linux-based system. So this can be already applied if you have Linux system in your factory, and if not, a Linux virtual machine can be installed in order to proceed with the software. Then, Docker software also is needed to be installed because all library packages are developed under this format. The IP address of your system needs to be known also, or the virtual IP address if you're using a virtual machine, in order to program correctly the installation. A PNG image called demomap.jpg, which can be found in the documentation, is needed. A basic knowledge about Linux is recommended in order to use commands and installation routines. The installation of the OPIL library server can be found in more details in the documentation section in RAMP. So, Docker, for people that they're not aware of, is a set of platform as a service products that use OS level virtualization to deliver software in packages called containers. Every module of OPIL Logistics Automation Library is uploaded on Docker, where it can be downloaded and installed in your machine. In a hardware point of view, the OPIL Logistics Automation Library would look like this. OPIL server with its central components, Task Planner, ASP and HMI, connected with the context management module, and then this connected locally with an AGV and its local components such as SAN, RAN, and local SP. HMI in its way also connected with the platform server through a PC and another SAN situated in a sensor computer, also connected to the OPIL server. And now, more hands-on guide through the installation of the OPIL library. When Docker and Docker Compose has been installed, we can check with Docker v and Docker Compose v command to verify their installation. Some info of their version will appear, and we will know that everything works correctly initially. Then, we can start preparing the Docker Compose YML file. First, we create an OPIL directory in our system and we create a file called Docker Compose YML. Then, there, we copy and paste the code we encounter in the OPIL documentation as seen in this slide. This will create the basis of the middleware of the library, its three basic components: MongoDB, NGSI proxy, and Orion Context Broker. This file will be updated with more code as we will be pulling more packages concerning the library. Then, when we will download the demo layout PNG from the documentation, we can give a small example on how we configure the arrangement on the factory floor plan. In the image, you can see the floor plan of the factory. This brown box is a pallet stack that is movable. Near the center of the image, you can see an AGV, and the floor plan area, it is divided in 3 parts. One is the production area, the red one, which has some conveyor belts and the pallet. The other, on the right, is the packaging area, where components are packed, and on the bottom left, there is the warehouse area, where AGVs can stock their pallets.
And now, how do we work with the floor plan? First of all, we have to determine a 0 point where we can define all the commands. The 0 point has to be selected with a specific mentality. It is a fixed point on a fixed structure on the factory floor. It has to be accurately aligned with the layout and the physical factory floor, and it has to serve as a reference point where distances can be easily measured from other locations, such as the warehouse, allocation of the pallet, etc. How are we going to do that? How are we going to define a language of measuring distances using calibrated coordinates? We start by this red line on the picture that we already know that in the physical factory is a distance of 28 meters. To define the scale, in order to work with a platform, we count how many pixels exist within this line with any imaging software. So, this distance is found to be 1,432 pixels. Making the division 28 over 1,432 gives us the result 0.019553. The result has to be multiplied with the pixel coordinates in order to work in the new scale. So, 0 point measured by the bottom left start of the axis is x equals 659 pixels and y equals 383 pixels, which corresponds, after multiplying by our scale number, to x equals minus 12.88 and y equaling minus 7.48 meters in the floor plan. We keep this useful information for later on. Then, we also have to define the annotations. Annotations are labeled positions of importance in the layout. Such labeled positions could be pick-up and drop-off locations, charging stations, or pallet stacks. The annotations you will be working with during this guide are all pallet locations and one charging station. These are pointed out with different colors in the image. Each annotation can be defined with 3 values: x position, y position, and theta, which is the orientation that defines the approach direction, so that an approaching AGV has its heading towards the annotation, as you can see on the right side of the image. On the bottom left of this image, you can see a coding example. Pallet WH_1, situated in the location x minus 5.4 and y minus 6.0, which is being approached by an AGV from up to down direction.
A few more words on the file creation. Without getting in specific details, the idea is to continue on creating the operational files with copying and pasting content found in the OPIL documentation. So, you continue creating the following files in the OPIL directory: demo map YAML, annotations INI, topology.launch. Please be careful when defining the IP address. If you're using virtual machine, be careful to put the IP address of the virtual machine. Then, you have to create JSON files as seen in the documentation to control the Phyros module. Keep appending the appropriate content in Docker Compose YML file found in the documentation to activate one at a time the HMI, Task Planner, and SP modules, which form the middleware of the OPIL Logistics Automation Library. So, when all these files are created, as also seen in the documentation, we will be able to pull all these containers from Docker. Just by typing sudo docker compose app -d Orion we can see in the screen the first 3 containers to be installed by the indication Done. You can check the module status by typing sudo docker compose ps. If the modules have been installed correctly, you will see a list of them with the indication up. If not, then probably something went wrong and you probably have to start all the process again. Then you can pull the HMI module following the same command seen on the image, and once again you can check the status by typing sudo docker compose ps. Seeing all the packages up means you are in the correct path and you can continue with the installation. The basic middleware of OPIL Logistics Automation Library is now already installed in your computer, and you may now proceed on having a first view of the interface. By opening a new browser and typing http localhost or the IP address of your virtual system, you will be able to see the initial screen of the OPIL interface. As the software is constantly updated, it's possible that the image shown here is not exactly the same, but it has the same functionality. By logging in with a proper user ID and password, you will be able to access the HMI module of the platform. By entering the interface, you will have a menu of tabs to navigate: Overview, Floor Plan Management, Task Management, etc. For example, going to Floor Plan Management, you can upload your floor plan. You define the floor plan name, the scale, and the X and Y offset to define the 0 point, the center of all your tasks and actions, as you can already see in the uploaded image here in the center of the screen. And that will be all about the installation of the OPIL Logistics Automation Library middleware. More on the modules will be presented and explained in the following video. Documentation of the OPIL Logistics Automated Platform regarding the installation files, JSONs, images, and guidelines for the OPIL server can be found in the link on the screen, as well as all the OPIL Automated Platform modules to be downloaded. And that was all about the installation guide. Thank you very much for your attention.